I am the tofu golem. Please enjoy the video.
You begin by preparing both the environment and the data so training runs predictably. Install Tensorflow and confirm GPU drivers if you plan to accelerate. Once done, load your labeled dataset and immediately split into train, validation, and test sets to avoid leakage. Next, normalize or standardize features and convert data into a TF. Dataset pipeline for batching, shuffling, and prefetching. This reduces I/O bottlenecks and makes training deterministic, which is crucial for reproducible experiments. You now define and train the model, focusing on practical choices that affect performance. Choose TF, Keras, sequential for simple stacks or the functional API for complex graphs. Design layer sizes and activation functions based on task complexity. Compile with an optimizer like Atom, choose the correct loss for your labels, and add metrics for monitoring. During fit, employ callbacks, early stopping to avoid overfitting, model checkpoint to save best weights, and reduce LR on plateau to adapt learning rates when progress stalls. You finish by validating, exporting, and addressing failures so your model is deployable. Evaluate on the held-out test set and examine confusion matrix and per-class metrics to find weak spots. Once satisfied, export as a saved model or convert to TensorFlow Lite for edge use. If results are poor, check for data leakage, incorrect labels, inappropriate learning rate, or mismatched model capacity. One key troubleshooting tip. First, lower the learning rate and inspect training/validation curves to distinguish underfitting from overfitting.
Thanks for watching. Consider subscribing if we helped you today.